Hi, I'm Ray, and I'm getting ready to start my solar project, and I wanted to share it with you as we moved along. I've got all the components together finally, and what I'd like to do is show you what I've got. Okay, so what you're looking at there is a Conergy 235 panel. It's rated at 235 watts. It's a 24 volt panel. It produces 8 amps. This type of panel is designed for a group of panels usually put together in parallel with each other to create a bigger system or an array. But in our case, we've got one panel. It's damaged. It's been shattered in several places from a drill being dropped on it, and so the pane of glass that protects the cells is shattered, but it still performs just fine. The only thing I'm not sure about is whether or not I'm going to have problems with the moisture getting into it when it rains. So I'm going to try and figure out what I'm going to do with that. Perhaps throw some silicone in where the holes are, but ultimately it's still got little cracks everywhere, so water would seep through just about every square inch of that thing anyhow. So I don't know, perhaps I'll just keep it out of the rain altogether, or if it's going to affect the panel at all, I don't know. So anyhow, I've got that, and then I've also went and picked up these bad boys here today. These are a couple of golf cart batteries. They're rated at 6 volts, and I'm going to put them together and connect them so that it creates a 12 volt application. And so I'll have that and my panel board here, which is currently just a blank slate, and we're going to go ahead and start the design of how we're going to lay everything out. And the first thing to notice is the juice will come in to a disconnect right there, which I've got a fuse in there, and then from there it'll go directly to the charge controller right there, and the charge controller will convert the 24 volt panel input to 12 volt output, so that way it'll charge these two 6 volt batteries, which will be paired up to create a 12 volt battery. And then I will draw my juice from this Monster 2000 watt inverter. It's a modified sine inverter, so it's not quality output, AC output, but it produces enough output so that I'll be able to operate many devices. Hopefully I'll expand in the future and be able to really take advantage of this. I suspect I won't be able to draw as much as I can because, well, as much as that allows me because of my limitations with my storage, that and my my module. So right now it's kind of a bare bones system, but I think it's big enough to where it's going to allow me to play with something and grow into something as well. So that's what I've got so far, and we'll come back with you as soon as I wire some of this together and show you the process as we move along. Okay, so I've got my fuses plugged in, and you'll note right here that the charge controller is reading that I've got a full battery, and the green light right here says that it's charging, or red that there's an error. When it's blinking, there's not really anything happening. I believe it will be a solid green when it's charging. We'll find that out tomorrow when I get the panel finished wired up out there. I've got the the leads coming in for the panel, but I don't have it hooked up yet. Alright, so for my load, which I intend to run constantly, I've got this fan that I'm going to use to blow one level down here on to my batteries to exhaust all the hydrogen that might build up underneath to prevent anything from, you know, exploding. So as you can see, batteries are charging this fan, and it currently works just fine, and it oscillates. Okay, so what we're going to do now is we're going to check and read the voltage coming out of our alternating current to see what we're getting and to make sure that it's coming in right. We should be getting 110. It's your standard outlet here, so let's go ahead and kick our multimeter on here and we get it in the light. So if you can see it there, we're getting 114, 115. And again, this is not clean, this is a modified sine inverter. So the power is going to fluctuate a little bit because it's more digitally converted as opposed to like an analog sine, ergo the name sine inverter, pure sine. But it's perfectly acceptable for what we got here, and that's exactly what we want to see. All right, thank you. That's it.